Difference between 789 and 787B. Typically, your transmitters and transducer in the field are passive devices. In other words, they will need external power to power up the device itself. Normally, we work on 24 VDC. Fluke 789 has the option to provide 24 VDC to power your transmitters. If you move the selector switch over to this, you will show loop power, and on display you'll see the loop power as well. This will enable you to power up your transmitter through the Fluke 789. Measurement or reading of current can be taken across the transmitter or transducer terminals. But in order to read milliamp, most of the time you'll need either a hard resistor or 250 ohm one to be terminated across the terminal. Fluke 789 has this option to provide a 250 ohm hard resistor so that you do not have to use an external resistor to simulate this function. On this selector switch, you'll notice a 250 ohm hard. By pressing this blue button, 250 ohm hard option will light up on your display itself. General understanding. Fluke 789 is a combination of both a basic multimeter and a loop calibrator. You can use the Fluke 789 to do basic multimeter measurement, DC-AC voltage, DC-AC milliamp, ampere, as well as resistance and diode tests. If you need to perform injection of milliampere, it also allows you to do this test over at this selection. This is especially useful for dual craft technicians or engineers who are taking care of both electrical and instrumentation. Electrical will be the multimeter functions. Instrumentation will be the injection of DC milliamp to verify the hard transmitters, transducer in the field. So if you are talking about simulation, you need to plug in the black or common receptor into this port. The positive connection to be on the milliamp selection, and if you are on to source mode, the negative or common connection will be on this receptor, and the positive connector will be placed into this receptor. Simulation. Injection of 4 to 20 milliamp to the transmitter or transducer to verify the AC milliamp value to correspond with the correct physical parameters of your device itself. So in this manner, we are taking in the consideration that the loop power will be provided by the controller itself. By turning the knob over to the milliamp output and connecting the connections as follows. Black connector is connected to the common receptor of the meter itself. The positive red connection will be terminated at this receptor. With this, we are able to do a simulation check. Sourcing. Your transmitter and transducer typically will require a load power to drive these devices. If you need to down your device, or maybe take out the transmitter or transducer and bring back to workshop, you can use the Fluke 789 to provide the loop power while simulating or sourcing your 4 to 20 milliamp. By turning your selector switch over to the milliamp output and connecting your black connection to this milliamp receptor, as well as connecting the positive terminal to the ampere rate receptor, you are able to source 4 to 20 milliamp to your transmitter. RAM check function. Basically, if you need to perform a quick check to verify what is your zero span to full span, you can use the Fluke 789 to do this function. Turn your selector knob all the way to this milliamp output with different run cycle, and the blue selector switch to choose what option you want. So on the physical connection side for your connection cable, the black connection will be plugged into your milliamp socket of the meter. The red socket will be plugged to the ampere receptor of your 789. Over at this side, I'm using a multimeter to simulate the display of your milliamp. Connections as follows. The black go to your common. The red will goes to the 400 milliamp. And I'll turn the receptor to milliamp DC selection. Terminations as follows: black to black, red to red. So as you can see, it will start to ramp up, and we choose the other option. There are different variations, up and down, or you can have ramping up with a certain delay. In this sense, we have the 30 seconds delay. This will be useful for you to quickly verify what's your 4 to 20 milliamp check. Caution and warning. The Fluke 789 has a few warning or caution that you have to take note. To take note of this, following caution: number 1, the voltage should not exceed 40 volts itself, and the current should not be existing or going higher than 1 amp for 30 seconds. Current, I'm referring to both DC and AC. So if your current reading is about roughly maybe 2 amp or 5 amp, what will happen to the meter is that the fuse internally will blow. Caution and warning. So basically, when you're using your process meter 789, you notice occasionally your fuse might be blown, or you suspect it to be blown. You can do it two ways to verify whether a fuse is blown. Firstly, the old traditional method, removing the fuses from your meter housing and verifying whether the ohmage is open circuit or otherwise. The other option will be a quicker method, which I'll show you shortly. Connect the black receptor over to the common port. Connect the red terminal firstly to the milliamp. Turn your selector switch over to milliamp and ampere. Over at the other end, you will require a multimeter. Black to common, red over to the ohms section. Turn your selector switch over to ohmage, and you still see roughly about 14 ohms. This will show that your fuse for the milliamp portion is okay. Next, repeat it for your ampere. Remove the red socket from the milliamp receptor, plug it to the ampere side. Look at the ohms reading on your multimeter. You should be ideally about 1 ohms. So this shows that both fuses are working fine.